Okay, so let's take a look here. So homework, we were supposed to make our dude, count backwards? Something like that? All right, so kind of taking the logic we learned last time. So a couple things to point out here. For some of you, this assignment probably felt trivial. Okay, one of the reasons we take these little tiny baby steps in here is some of you, your mind is going to take to this programming logic more quickly than others. So just because you felt it was trivial doesn't mean that you might have somebody in here who thought it was almost impossible to do that. Okay, so the punchline is we have to take little tiny baby steps. So we're going to have a lot of assignments, but each assignment is going to be relatively smallish for now. Something like that. Okay, so let's see. We'll go to the edit code thing. So right now the which is starting with, so we're gonna do something 10 times. We're starting with the which's count. If the which's, we were trying to do, this is when I was trying to do the modulus stuff, right? All right, so let's drag that out of there. So we're gonna do something 10 times. We're gonna start with the which's count. And we probably want to just start the which's count off at another value. So we can go in here and we can set, this is the scene currently, the which. So we can set the which's count equal to, what did I say, 10 to 0 or 10 to 1 or 10 to 0. So we'll start off at 10. So we set the property equal to 10. Then we'll go ahead and count 10 times. We're going to go ahead and ask the which to say something. The which will say, well, for right now, let's just say the count equals something like that. And then we're going to expand this to be concatenated with, is it one of these guys? This dot which. We want to get property, right? So was it? So we already have it saying count equals. We need to get that second part changed. So I guess for now, what is it? Set it to hello, and then scroll down, and we're able to just drop the value in there. Get count. That. All right, so we're able to which say count is equal to their current value of get count. So I'll start it off at 10. So we started it off at 10. So we're going to do something 10 times. We'll print out, we'll say the count is count, and let's give it a duration of 1. Then we're going to modify the value of count. So count is equal to whatever it used to be. We're going to switch this to a -1. So it goes from 10 to 9 to 8 to 7 to 6 to 5, so on and so forth. And then we'll spin back up and we'll do this a total of 10 times. All right, so for right now, let's just get rid of this extra crap. Do that. We'll come back in and do that stuff. So we have to figure out the modulus stuff. All right, so let's go ahead and play this. So 10, 9, 8, 7, 6, and I think we can we speed through this? All right, so that counted down to 1. So we actually need to do this 11 times if we wanted to go to 0. and then we're going to change this up a little bit. Custom whole number, do this 11 times, go ahead and run it. So there's our 0. Okay, so we're going to now modify our loop a little bit. Right now we're doing a repetition loop, doing something some number of times. Well, last time we started looking at asking questions, right? So maybe the idea is that, well, actually, let's start with the asking question thing again. So we want to do an if statement. We'll start off as if true. And what we really want to do is we want to find out if there's a math function. So we're going to, let's go ahead and get the, oh, I can't land it there. So we could do math on this guy. So if, oh, that was the problem. We couldn't figure out how to get the, it's less than or equal to, it's that. All right, so let's do this. Just give it something for right now. So we want to throw the which's, won't let me drop that in there either. This was our problem from last time, right? So what we want to say here is we want to ask the question, is the which's count evenly divisible by 2? And I think we were able to print something so we can tell the which to say something. And we can modify what she's saying to be a math formula. And we can get the count. And then we can change this to, where were we getting the math portion of it from? Because that was our problem. We found the integer division in one dropdown, but not in another. Let's do this. I think we did it inside of our set count. So we'll just set it to 0 for a second. We're going to change this guy to some math. And there's the division remainder. So we could do integer divide. Okay, so this is a, all right, I think that's the way we need to do this. It doesn't look like we can ask that question as part of a if, but we can certainly set a value equal to the answer of that integer division, then ask about the value of that property. So let's do that in 2 steps. So I'll show you what I'm saying first, and then we'll see if we can come up with the other way of doing it. So we're going to go into our which, and we want to add a property. Was that in here? Which, add a which property. For lack of a better name, let's just call this guy temp value for right now. So this is going to be a variable field. We're going to use it as a whole number. So let's call this temp integer. Temp int. All right, and we can set it equal to 0 as the starting point. So we'll hit OK. So now a which has this brand new property. All right, so now we're going to go ahead and, are we okay with this loop here? Is there any questions? This was the homework assignment? Went okay? All right, so let's go ahead and delete this. So we're going to set the count to 10 to start off with. Then we're going to ask a question, but before we do that, we need to set another variable. So we're going to go ahead and we're going to set temp int. And we're going to start off at 0 here. And we're going to start it off as get count, except I could switch this to a math function. Division remainder. Okay. And so we want to do the remainder of the current value of count divided by 2. Okay, there we go. So we're going to set temp int equal to the current value of count divided by 2, getting the remainder. So 10 divided by 2 should be 5, remainder 0. Okay, so now we should be able to ask the question, if get temp int, let's dump this. Why is that set as a decimal number right now? Just get rid of this. Oh, here, relational whole number. So this is decimal versus whole numbers. We want to do whole number equivalence here. So we're going to find out if something is equal to something. So we want to ask, is temp int equal to 0? If it is, that means we had an even value, right? Okay, so we'll go ahead and get temp int, drop it in there. If temp int is equal to 0, if that's true, then what do we want to do? We're going to have the which yell something out of procedures. So custom even number. Otherwise, we'll have the which say odd number. And we'll put a little delay on this of 1 second. All right, and then let's go ahead and get rid of this and get rid of this. All right, so we're remembering 2 things up here. So this is our memory. First thing is we're going to set the count to 10, just hard coding it to 10. Then we're going to set temp int equal to the result of some math, taking the current value of count, which is 10, and dividing it by 2 and record the remainder. So set temp int, temp int will equal the remainder of count divided by 2. Then we're going to ask a question. If temp int is equal to 0, we'll go ahead and say even number for a second. Otherwise, we'll say odd number. So right now, this should say even number, right? Go ahead and play this. There's our even number. If we close this, if we set temp, or set count equal to something else, let's set it to a 3, which should be an odd number. Now, the which should say odd number. So the which is now able to detect even versus odd. So we'll leave it at that for now. There might be a way of doing this math inside of an if here, but I couldn't figure it out. So that was in this if. So that whole thing's going to be a Boolean. This guy could be a math. So that gives us division remainder, but what will this give us? Math. Get count. That's weird. Why did it work? Did I do something different there? So we're avoiding using our variable now. I'm still using it, but I'm able to directly ask the question. I'm going to get the which's count. I'm going to divide it by 2, And if the answer is equal to 0, then print this out, which means we didn't even need to use temp int. Didn't we try to do this exact same way before? So I have a feeling that there's going to be some stuff like this with Alice where you kind of have to stumble into doing things in maybe the right order in order for it to do stuff, but creating the variable wasn't really a problem the way we did it. This should give us the same result as we had before. And actually it gives us a good thing to talk about here for a second. So odd number, we'll switch this back to an even number, so we'll throw a 2 in there, run it again, so it should say even number. Oop, row. Get count, count starts off at 2 and divided by 2, if it equals 0, it should say even number. Oh, thank you. Question is, are we ever going to be able to get back to that function? All right, so that was this guy here, 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 here. Oh, actually, I want to reduce this to left operand only, right? Okay, and then I'm going to get the count. So when we get the count and that's for that value. That should be for that value. Okay. And this should be 2. All right, so we'll get the count. We'll do the integer division, getting the remainder when divided by 2. If it's equal to 0, it'll be even. If it's equal to 1, it'll be odd. So this should now be even. If we change this to a 3, it should be odd. There's our odd number. Okay, so we've seen 2 different ways of doing the same thing. And one of them, we threw this logic right here inside of a variable and then asked the question about the variable. We said, is the value of that variable equal to 0? If it is, we'll print out even number. If it's not, we'll print out odd number. Then we're doing it this way, where instead of storing this logic inside of a variable, we're just asking the question directly. We're saying, if this is true, if when I do the integer division and I look at the remainder, it's equal to 0, then print out even number, otherwise print out odd number. And we've seen that we get the same result in our code right now, right? So the question is, when do we use variables? So we talked about at the beginning, first day of class, that human beings solve problems with memory, asking questions, and repetition. So memory is our way of remembering things. So what I'm really asking here is when do we need to remember something? If you had a rule of thumb, remember with the writing software, programming is the act of telling a computer what to do, and our language, in this case Alice, is trying to give us a power tool so that we can accomplish telling a computer what to do. In this case, we're telling this witch some stuff to do. So what would be a good rule of thumb for us to use for when we should use variables versus when we should not use variables? We just saw us solve the same problem both ways. So clearly we didn't need a variable there. Go ahead.
If you ever need to use it somewhere else again.
Okay. So if I need to remember this value because I'm going to use it more than once, I probably should store it somewhere, right? If I'm only going to use it one time, I could just use it and not have to store it anywhere. Now, fair enough. I think that's a fair enough assessment. So if we need to use the value more than once, we should store it somewhere rather than compute it multiple times. Now, is computing it really that big of a deal? I mean, we could certainly just ask, is this number even or odd again, right? And then just use that value. We've lost out on some fraction of a nanosecond or something like that. Oh, by the way, if you guys didn't see it, I shared the post on Facebook, but it was on the Grace ACM Women's Computer Science thing we have here. It was on their Facebook page. A video from Grace Hopper about explaining what a nanosecond is. If you didn't watch it, it's pretty interesting. Because when you're explaining to somebody kind of a little tiny piece of time, that's not human time, right? You talk about how long a nanosecond is. What is a nanosecond to any of us? It's nothing, right? It doesn't take any time whatsoever. So she describes it in terms of she creates a wire. So taking something we already understand, she said, well, here's a wire. The wire was like 11.5 inches long, I think. This is a nanosecond. So she was trying to explain to some politician. She actually kind of makes fun of politicians, so it's quite interesting. But, somebody was complaining about how long some satellite thing was taking. So she was trying to explain to them how many of these 11-inch nanoseconds it takes to get to some satellite in space to kind of explain time. So it was fairly interesting. And then she had, she handed out, I think, to the group a nanosecond for each. She handed out a nanosecond to each person in the audience. But then she said, well, let me show you what a microsecond is. But she said, I only have one of these. So she reached into a backpack and basically just pulled out this bundle of wire. It was like, I don't know, 100 feet long or something like that. So I don't have these to hand out. But it was an interesting way of explaining these time periods that are things that are helpful to us in computing, but not necessarily things that we measure time in terms of humans, right? You don't, if you're going to be 5 minutes late, you don't text somebody and tell them how many nanoseconds late you're going to be, right? You say 5 minutes because that means something to a person. As opposed to, I guess, 5,000 milliseconds is 5 seconds. So you can just scale the math, and all of a sudden you're giving somebody this giant number. I'll be there in 165,000 milliseconds. So that's not a human thing. So how that relates to what we're talking about here is from our perception as a human being who's running this, we're not going to notice the difference on a one-off if we store the value of the integer remainder versus compute it twice. We're not going to notice. But now if we do that same math 1,000,000 times, now we might notice. That's a lot of work happening under the hood. That makes sense? So something to consider in more of the big picture stuff that this is a good rule of thumb. This is probably best programming practice. Okay, best programming practice is if you're going to need a value more than one time, store it somewhere and then retrieve the value the 2 times or each time you need it rather than compute it again. Now, having said that, if you're going to use it exactly 2 times, maybe it depends on whether or not you're in, which do you have more of? Do you have more computing power or do you have more memory? Something like that. Or what am I storing? If you're storing something that is 10 gigabytes or something like that, maybe it's better to just retrieve it again in maybe the unlikely scenario you might need it. So let's say that we have a value that we know we need once. We might, under very specific conditions, need it again. So now we need to ask the question, do I store 10 gigabytes of data for the just in case I'm going to need it again scenario? And maybe it's, the user the moons have to align and the user has to click on the correct number of menus. Pretty similar to Alice, it seems like. So for us to get certain menu drop downs, does the user have to click on certain things in just the right order to technically get to a situation where we need that value a second time? Do we store 10 gigabytes for that 1% chance, or do we just risk having to compute the 10 gigabytes a second time? Yeah, there isn't a correct answer to that. So this is a pretty good rule of thumb. We use variables. We remember things in real life when we might need it again, right? That's why we memorize stuff. When you're studying for an exam, you What do? You give your little cheat sheet, right? And well, some of you probably bring the cheat sheet with you to class. But generally, what you sit there, you just keep looping through, over and over and over again until it's just ingrained in your soul, right? That way, when you get to the exam, you can, it's fresh in your mind, and then you immediately forget everything you just studied when you leave the exam. And this is, an interesting thing. So, and some of those things stick with you. Does anybody in here, do you remember something weird that you have no use for now, but at some point in your life you memorized something and it's just still there? For me, it's the Greek alphabet. I don't remember what grade it was in. But in any case, I don't think they do this anymore. But I had to say, the assignment was we had to say the Greek alphabet as many times as we could on a burning match. So the teacher was trying to burn us. Is the whole. Do they spank people in school? Oh man, first grade I got hit 3 times. Yeah, one time was we were grading each other's spelling tests, and it was the smartest girl in class. I wanted to mark something wrong, so I changed the spelling of cat, I think. But she had like really nice handwriting, and I did not. So it was like very clear I altered this. Yeah, so I got hit that time. I ate crayons another time, I think. I don't remember the third time. I think she might have just wanted to hit me. There might be some truth to that. Which is funny, because years later, she went to the same chiropractor I went to, and I was substantially bigger than her then. Yeah, but in any case, the whole Greek alphabet thing, I practiced this thing so many times. I could say it I think 35 times on a burning match. I got so fast at saying it that is just ingrained in my soul now. So, I might not know what all the symbols are, but I can say the alphabet. But in any case, typically in real life, we remember things that we might need to recall again. We remember our address. We remember our phone number. We remember our name, hopefully, right? That kind of stuff. Okay, so this makes sense. Good rule of thumb. From our perspective, since our computers typically have plenty of memory today, we might say it's never wrong to go ahead and throw a value into a variable for convenient use later. Even if we're just doing a bunch of math right there. Let's say we have kind of a complexy math statement we're going to do. We have to multiply some stuff and then divide some stuff all in one big scary line. We might decide that it's more convenient for us to break that problem down into 3 steps, store each individual subtotal, if you will, in individual variables, and then bring all those variables together to get a final answer. That might be less intimidating, less crazy Alice drop-downs, stuff like that. Okay, some things to kind of consider as we're going through this. But that's when we want to use, you need a variable if we're going to use something more than once. Okay, in this case, since we don't necessarily have a reason that we're going to need this value again, it's reasonable for us to go ahead and just throw it inside of, not throw it inside of a variable. All right. So now, let's go ahead and let's throw our loop in here again. So we'll go ahead and we're going to count something. Let's do this 10 times again. And what are we going to do throughout here? Well, we're going to start count off at, let's say, 1. We want to keep going through count 10 times. And then we want to print out, can we get it in there? So we just dragged our if statement inside of this loop. So we're going to ask this question now 10 times. Okay? Each time through, we're going to ask, is the current value of count an even number? If it is, print out even number, else print out odd number. Then we want to set count to a new number each time. And I'm just going to start off at 0. And then we're going to replace this with some math. So let's just do that one, that. So we're going to set the count to some value plus 1. What value? The current value of count plus 1. So that'll update count. So it'll be 1, then 2, then 3, then 4, then 5, so on and so forth. And we'll say even number or odd number. Now what we can do here is let's go ahead and show the value of count. All right, so we're going to, I'm going to throw a couple of values in there. We're going to say hello, and then we're going to say custom string is even. Similarly, I'm going to replace this guy with hello custom string is odd. And then we'll replace our hello with our get count. All right. So each time through, the which is going to say the current value of count is even or the current value of count is odd. All right. And we're adding 1 to it each time. So we should see 1 is odd, 2 is even, 3 is odd, 4 is even, so on and so forth. So go ahead and run that. 1 is odd, 2 is even, 3 is odd, 4 is even. Oh, I seem to be more excited about even numbers. I put the exclamation point on there. All right, so now that's just counting up directly. But what if we set count instead of this? What if we just set it to a random number? So next random integer from 0 up to, but excluding, let's see, let's do from random integer from A up to and excluding B. Okay, fair enough. Oh, we can do including. So we're going to start at 1, and we're going to go up to 10,000. So now each time through, we're going to update count to some random number between 1 and 10,000, including that 10,000, as opposed to excluding that 10,000. So, 9,999 would be the excluding, including will go all the way up to 10,000. So now this which is going to be getting a completely random number each time through, except for the first time. We can give it a random number the very first time if we want. So here we'll say random value excluding up to but including. So we'll say 1 to 10,000. All right, so right off the bat, the which is going to get a random number between 1 and 10,000. We're going to go through 10 times, print out whether that number was even or odd, then update it to another random number. All right, so we'll hit run. 1681 is odd, so on and so forth. We're seeing random stuff. All right, that makes some sense? All right, so now let's go ahead and we're going to create a guessing game. So we're going to generate a random number. And then we're going to have our witch guess the number until she gets it right. So we'll start off 1 to 10, just so we can keep it kind of reasonable. So this is kind of like us playing the guessing game, right? So I'll come up with a number in my head, and then you keep guessing the number, and then I cheat by pretending like you haven't guessed it yet, right? But so I'll come up with 3, maybe you say 5, I say no, you say 7, I say no, finally somebody says 3, and that's right. We maybe count the number of tries it took to get it right. Okay, so very first thing we're going to do is we're going to set some values. Now what I'm going to do here is we're going to, because technically the witch isn't necessarily the one who is, the witch can't play this game with herself because that's cheating, right? I know the number I thought of, so I'm going to get it right the very first time. So we're going to need to throw another dude out here. So let's go to the setup scene. And let's see. Who will... The dragon? Well, I think there... Aren't there other... Let's let's get out of the, can we go back to, could have a panda or phoenix. Or it can just be the weird shrine that comes up with. I think we should do that. Okay, so, oh wait, that's not the actual shrine. This is the shrine. How big? How big? Oh, that shrine is huge. We're not using that. I guess we can shrink it. It could be a baby shrine. All right, so that's our shrine. And then let's see. So size, that moves it. Resize. Oh, that's the witch. So why make the shrine big, smaller when you just make the witch big? Oh, there we go. All right, little baby shrine. Okay, so we're gonna teach the shrine to come up with a number. All right, so let's get this. Oh, let's. What have I clicked on? I thought I clicked on. Oh, I need to move this dude. Oh, it's this one. Oh, I just drag? Oh, there we go. That's directional. All right. Fair enough. All right, so the shrine is not going to have a number, so let's double click on, we've got to go, what, edit code. All right, so right off the bat here, we're going to go in here, we're going to click on our shrine, and we're going to add a shrine property, and we're going to call this guy secret number. And our secret number is going to be a whole number, and we'll initialize it to a 0 for right now. We're going to give it a random number. Okay, so now at the beginning of this whole thing, we need to go ahead and we need to have the shrine set that initial number. Start off at a 0 there. We'll replace this. So we're going to have a random number from 0 well, we'll just do 1 to 10, including. So 1 to 10. All right, so the shrine has set their starting value. Now we're going to have the witch count how many times it takes her to guess. So we're going to repurpose the witch's count variable to be 0. So the witch is going to keep track of how many wrong guesses she has. Okay? So now we need to keep doing something until the witch finally gets the right answer. All right, so we're going to write this in terms of what we've already done first. So let's just delete this to clean this up. Delete that. And we're going to go in to our witch. And here's our temp int property. Can I change the name of it here? Rename. And we're going to change this to current guess. All right, so the witch knows about a count, and the witch also knows about her current guess. 2 pieces of information the witch will remember. All right, so let's go back to I want to get back to the code. My first method, here we go. All right, so the witch is going to know that, so we're going to have the witch make 10 guesses for right now. We'll just stick with our current logic till we introduce the next loop. So now we're going to go ahead and we're going to have our, select our witch here. We'll have our witch generate a guess. So we're going to have our witch set her current guess to a number. We'll start off at 0, then we'll modify that to a random number between, and now the shrine is mumbled to the, we'll actually make the shrine mumble to the witch. Pick a number between 1 and 10. That's our range? 1 and 10? Okay, so we're going to say 1 to 10. Before this even starts, we're going to have the shrine go ahead and mumble something. So, well, the shrine say, pick a number between 1 and 10. All right, so this is kind of burning bush mode, Moses, and all that stuff. So it's just like a weird shrine. We should actually get a burning bush and a Moses. That would be very Concordia-like. Okay, so in any case, we should actually look for that at some point. Then bring Dr. Locklear in and it's like, the burning bush is just the core of this entire game. All right, so the shrine's gonna say, pick a number between 1 and 10. We'll say this for 2 seconds, let's say. And then the witch is gonna make 10 guesses. So she's going to set her current guess to some random number, and then we're going to check to see if that guess is right. So we're going to ask, is the witch's current guess equal to the shrine's secret number? All right, that's what we're asking. We're going to do this all inside of this method right now, but later on we would probably have a way for us to say, shrine, is this the number you're thinking about? And the shrine takes in that number, magically decides whether it's the number that it was thinking about, and returns a true or false or something. But right now we're going to keep all the logic right here. So the witch figures out a number she wants to check. Then we'll go ahead and give ourselves an if. We'll start off as true. So we want to know, is the witch's current guess equal to the shrine's current secret number? Or shrine secret number. So if whole number relation equal, so we'll just say 0 and 0 for right now, the first number here is going to be, we'll actually have to drag it out here. So we want to know if the shrine's secret number is equal to the witch's current guess. If that's a true statement, we're going to go ahead and say, actually here, we'll make this nice and fun. So the witch is going to say this is the number space, and we'll do a concatenation deal here. We'll start that off at hello, get current guess. So the witch will say, is the current number whatever number she came up with. Then the shrine is going to ask itself that question. And then the shrine will say, click on the shrine up here. If they do match, you got it. If they don't match, try again. Sad face. Okay, and we're going to give the witch 10 guesses. All right, so we'll go ahead and run this. Pick a number between 1 and 10. Is it number 3? Try again. Number 8. Try again. It's like exhilarating finding out if the witch is going to win this. And the witch sucks at this game. Ooh. Ah! Okay. All right, so we're going to update this a little bit. We would prefer for the, once the witch gets it right, we would prefer that the witch no longer has to keep guessing. That we should spit out what happened. So we want to keep track of the number of wrong guesses the witch has, right? So we're going to go in here. We're going to grab the witch, go to procedures. We're going to actually click on the witch. We're going to set the witch's count on a try again equal to, we'll start off at 0. We'll replace that 0 with a math something plus something. Well, we'll just start with this. All right, so we want to get the second value here will be a 1. The first value here will be the witch's get count. So we're going to add 1 to count. So on a incorrect guess, when the witch is told try again, the witch will update their count to be 1 bigger than it used to be. All right, that makes sense? So we'll let the witch keep going through here. Now I'm going to introduce this other guy here. A while loop is like an if statement that repeats multiple times until some condition is true. So we can say here, while I'm going to copy this. I'm going to try to copy this. Can I copy that? Well, apparently not. All right, so we're going to ask the question while whole number not equal to, we'll say 0 and 0. So while the witches, well, we'll start with the shrine, get secret number is not equal to the witch's guess. So with that in mind, does a witch have a starting guess? We'll have to set the guess here in a second. Let's just do that real quick. The witch's get current guess, and then we want to go ahead and set the witch's current guess before things start off to -1, which would not be a number between 1 and 10, so we're guaranteed that the witch will be wrong to begin with, right? So as long as the witch has not guessed correctly, let's go ahead and let the witch make a guess. Then we'll let the witch say her guess, and then we'll ask this question. And now we can get rid of this guy. Okay, so while the witch has not answered correctly, go ahead and the witch will come up with a new guess. It'll say its guess. The shrine will ask to see if it's right. If it is right, they say you got it. If it's not right, we'll say the count. And then we want to go ahead and in the end, the witch is going to say custom string, it took me space get count number of tries. All right, so we'll go ahead and run that. Let's just fast forward through this. Oh, well, it showed it got it right. So idea here for your homework assignment, because I know we're out of time, I'm going to take a screenshot of this. You have this as a starting point, but you also get practice rebuilding it. Modify this code to have the shrine give the witch a hint, too high, too low. And then have the witch modify her next guess based on that hint. So instead of a random number here between 1 and 10, If the witch guessed 5 and that was too high, then the witch should pick another number between 1 and 4. That make sense? So 2 dynamics there. Okay? The shrine's going to report how close they were. The witch will then update her guess intelligently based on that information. All right, I will see everybody on Friday.